let's go over the unary operators. First one is the unary minus. Okay, that just negates a number. So for example, if I say int my value, and I do cout my value, I can do this, and that just basically will negate the value 5, where I can say minus that plus 10 times 2. Okay, so what that's going to do is it's going to turn this into a negative 5, but you have to remember we're talking about precedence, and we're also talking about associativity. The precedence here comes into play because multiplication goes before addition. Okay? But you also have to pay attention, because you're dealing with an operator, which one goes first with the unary operators. Well, let's look at our chart. Okay, and what I mean is by the negation sign. The negation sign looks like will go first, and then the multiplication, which is 6, and then the addition. Okay, so what's going to happen with this expression, the way it's going to be evaluated, is it's going to first negate my value to negative 5, and then it'll do 10 times 2 plus negative 5, which would give you, that's 10 times 2 would be 20, 20 plus negative 5 would be 15, right? So let's try that, and there you go. You have the value of 15. Okay, let me backtrack a little bit. This unary minus is still considered an operator. Because it's unary, it only acts upon one operand. In this particular case, it would be this one operand. Okay. For example, another example I can give you is your unary operand could be something like this. Okay. So what do you think is going to happen here? Well, what goes first? Parentheses will always go first. So this will get evaluated, right? 5 times 2 is 10. Then it'll negate it, so it'll be negative 10. But now you have multiplication, which will give you 10 times 2 will be 20. 20 plus negative 10 will give you 10. And there you go. Okay, but again, you have to pay attention to the order of precedence as well as the associativity. Now, again, let me repeat this. This is considered one operand because this first needs to be evaluated to one value. This isn't a combination of two operands. It's one operand because it's in parentheses. So again, this is a unary operator. The unary operator can only act upon one operand. Okay? But that one operand could be a combination or an expression of operators and operands, as long as the remaining value or the result of the combination will result in one operand. Okay? Okay. Next is, we'll cover typecast, which gets one operand. Sizeof, which gets one operand. We went over the unary minus, the increment, and the decrement. Okay. Again, I repeat, binary operators have two operands. Unary operators have only one operand. So let's go over typecast. Typecast changes the data to another data type. But when you use a typecast, you're not permanently changing the data. You're only changing it at the time that you're using the typecast. And there's two types of casting, typecasting. There's implicit casting and there's explicit casting. Implicit casting is done automatically by the compiler. Explicit casting is done by the programmer, or it's programmed. When I explicitly cast a variable, that means I am using the typecast operator in my expression. But when the compiler implicitly casts a variable, or it could be a literal, then that means that the compiler is handling it and I haven't done anything programmatically to do a typecast. The implicit cast is necessary because sometimes you may find yourself mixing types. For example, if you mix a integer and a double, what'll happen is the compiler has to decide what the result is going to be. Let me give you an example. This is a simple one. If I do 5 plus 2.0, let's do division. 2.0. Okay. At that point, the compiler is looking at both values, and it looks at the 5 and it says, well, this value does not have any floating point attached to it. Then it looks at 2.0 and it says, well, this is a floating point value, so I'm going to treat it as a floating point value because of the 2.0. But then it says, I need to decide what the result is going to be between an integer, the integer is 5, right, and the floating point number 2.0. The compiler at this point is going to make the necessary implicit cast. Okay, now how does it decide this? It decides this by using something called an integral promotion. Again, it decides what it's going to cast it to by using an integral promotion. Okay, let's pause for a second so you can look that up and kind of digest what I'm trying to say. But let me pause for a second. Okay, what I wanted to do is I wanted to search the slide lesson that shows the promotions. I didn't want to waste time just recording how I search. As I mentioned before, the compiler decides at the point of implicit casting what the result will be once the expression is evaluated. Whenever there is a mix of types, it has to do something called promotions, more precisely called integral promotions. If you look at my slide, it shows you what each data type will be promoted to. In this particular slide, it tells you that if you have a char, it's always going to be promoted to an int. If you have a short, it's also going to be promoted to an int in an expression automatically. Okay? If I go on the next slide, you see that an int is lower than a double. Okay. So what happens is the double rules in the land of data types. Well, actually, long double rules. Double is probably second in command. What does that mean to you? Well, it means that if you mix the types with a double and an int in an expression, and you're guessing, well, what is the result going to be? The result is going to be in a double. Okay? So if when I do 5 divided by 2.0, okay, my result is going to be what? Who wins? An integer or a double? If we look at our chart and we fight the integer versus the double, you see that the double is on the top of the hierarchy chain, so that means the double will win. So what are you expecting for the output to be? Well, let's see. If you run this, that's right. Because an integer versus a double, again, the double is higher in the hierarchy, and the double will win and prevail during this. So you'll have your remainder intact. Okay? So what happens when you mix a float and an int? Same thing. If you mix a float and an int in an expression, the float is on the top of the hierarchy chain, so the float will win. Okay? Take a minute to do a couple of examples yourself and try and mix these data types and see what the answer is. Okay? The outcome of the expression will be the higher data type. Okay, and just like in this case, 5 divided by 2.0 gave you a floating point result, which is a double. Okay, let me give you another example. If I don't mix data types and I say int versus int, they're both obviously two ints, so it's going to be an integer result. So if I close this and I compile, it's going to give me a 2. Okay. Okay. That's what the compiler does when it does an implicit cast. It uses this hierarchy to decide what the output result will be. Okay. Now, there are times when you can cast explicitly on command. For example, let me take this out, and let's say I had int my val 1 equals 5, your val 2 equals 2. If I do a cout my val 1 divided by your value 2, you know that an int divided by an int, if you look at the implicit casting rules, it's going to do int, right? Because they're both the same data type. So let's compile and run this, and you're going to get 2. That makes sense so far. But suppose that for this particular moment, you want to get a decimal floating point result. You want to get a decimal floating point result. So you want to get 2.5. You don't want to get the 2. This is where explicit casting comes in. With explicit casting, you can cast it to a data type, in this particular case, a double, and your result will be a double. So how do I do that? Easy. You just put the data type that you want to cast it to in parentheses. Okay. If I do that, that means my value 1 is cast into a double. Okay. my value 1 is cast into a double. So if I do execute, compile, and run, see that? 2.5. Because at that particular moment, I've put a cast to double to my val1. Okay? But, again, it's at the moment of casting, so it's a temporary cast. It's not permanent. If I did this, my variable is still an integer. Okay, so if I do this, if I do compile and run, you have 2.5, and then you have my value, which is 5, which is still an integer. The data type only changes at the point of the expression execution of the cast. It does not change permanently. You have to realize that, because the typecast operator is only temporary. Okay? The next unary operator is the sizeof operator. The sizeof operator tells you the number of bytes that are allocated or necessary to allocate of the operand. So for example, if I want to find out what the size of an int is, easy. And again, this returns the number of bytes, okay? Number of bytes. Size of an int will give me 4, because there's 4 bytes in an int. If you always wanted to know how much space was in a double, how many bytes were in a double, it's 8 bytes in a double. Okay. Now, what if I declare a character string array called name of 20 bytes? What would that return? Let's see. Take a guess before I compile. 20. That's right, because my character string array, I allocated 20 bytes to it. Okay? And what the size of is going to return whatever I've allocated here, not the built-in one. Now, also, remember, if you want to take a look at the size of a literal, right, the way the compiler treats it, you can do that too. I can say, what's the size of the literal 295? How is the compiler treating that? How much space is a compiler allocating to the numeric literal of 295? And we can look. We can say compile and run. It uses a 4 bytes. It looks like it converts it into an integer literal. That's what it looks like. Okay? That's what it looks like. You can also get the size of a variable, how many bytes have been allocated for it, as we did with the char. So my val, if I compile and run, let me close this, 4 bytes. Okay? Now, here's a cool thing, alright? Remember how we were talking about implicit casting? Okay? Implicit casting. If I do 3 times 4.0, okay, what's going to happen is it's first going to evaluate what's the result of that expression. Okay. Then, but before it does that, it has to decide who wins the battle, right? So who wins the battle between a double and an integer? A double. And how many bytes in a double? It would be 8. So I'm expecting this to print out 8, because what's the compiler saying is the size of this. What the compiler is going to do is say, as a result of the integral promotion and double being the all-time king and ruler of integer, I'm going to return an 8, because that's how much space I need to store this result. And there it is, 8. Okay, so size of is very useful. especially when you're reading input. It'll tell you how many bytes to read on the buffer. Okay. Okay. So that's the unary operators so far.